This is a visual video of the exposure maintenance formula, direct square law, or mass distance formula. You can refer to this equation as any of those three. They all describe the same thing. So talking about with distance changes, you have to either increase or decrease your mass value to compensate for the loss of quantity, because as the beam diverges, less will reach a specific area. So if you get further away and the beam diverges out more, you have to compensate for the loss in quantity reaching the part, so you raise your mass value. And if you're getting closer, then there's a lack of divergence, which means more quantity will actually strike the anatomy, so you don't need as much mass. So the formula looks like mass 1 over mass 2 is equivalent to d1 squared over d2 squared. So notice it's a direct square law, whereas the inverse square law of d2 is over d1, so this is direct. Exposure maintenance formula, how to maintain the exposure with distance changes, is another way you can describe it, or a mass distance formula. The example I gave you here says that if you used 80 kVp at 12 mass on an abdomen at 40-inch SID and it was good, what would you use at a 48-inch SID? So if we go ahead and mark these for what we would use them for, first thing we come across is 80 kVp. Now, 80 kVp has nothing to do with our formula, but we will use that, so we'll just kind of make note of that 80 kVp. We used 80 kVp at 12 mass. Well, mass is in our formula. That happens to be the first mass value, so we're going to label this mass 1. Use that on an abdomen at a 40-inch SID, and that distance, 40-inch distance, happens to be our D1. And it was diagnostic or good. So what would you use at a 48-inch SID? That happens to be my D2. So what would you use? That ends up being my variable, my X, which is my mass 2. So if we set this up, then mass 1 is 12 over X equals D1 squared, which is 40, so 40 squared, over D2 squared, which is 48. Okay, so if I had my calculator, .40 squared is 1600, and 48 squared is 2304. So we cross multiply, and we end up with 1600x equals 2304 times 12, 27,648. Then we solve for x, so we divide both sides by 1600, and we end up with x equals 17.28, and that's mass. Okay, so I would need to use 17.28 mass, but if I go back to this, and I'm at a 48-inch SID, and I used 80 kVp at 12 mass at 40, then I would end up using 80 kVp at 17.28 mass at a 48-inch SID. That would be the answer truly to my question, that if my distance went from 40 to 48 inches, instead of 12 mass, I would need to raise my mass value to 17.28 to compensate for that change in distance. Okay, so that is how you solve the direct square law or density maintenance or exposure maintenance or mass distance formula. Again, the X ended up being on the mass side, so there was no square root of anything involved. But let me show you one more. where we actually change and put the x in the distance side and show you that that's going to play out where the last step is that we're going to take the square root of the number. All right, let's erase this. We'll leave the formula. Okay, so if you used 110 kVp at 3 mass at a 40-inch SID in an apartment, and it was diagnostic, what would you use on portables if you were stuck using 5 mass? Meaning, let's say the machine was stuck on 5 mass, you couldn't get 3, what would you end up using in order to solve for that? So 110 kVp is probably going to come in at the end, but has nothing to do with our formula. 3 mass, that ends up being our first mass value. 40-inch SID is our first distance. And if we had to use 5 mass, that is our second mass formula. So if we plug them in, our first mass is 3 over 5 equals D1 squared, 40 squared over Rx squared. 40 squared is 1600, so we cross multiply. 3 times x squared gives us 3x squared, and 1600 times 5 gives us 8,000. Divide both sides by 3. X squared equals 2,666.66 repeating, and then we take the square root of that, and we end up with x equals 51.63. We'll just cut it there, and that would end up being inches. So if we were stuck at 5 mass, we'd have to move to that distance. So on portables, you would use 110 kVp at 5 mass at a 51.63 inch SID. So moving from 40 inches to 51, your mass would increase from 3 to 5. Your kVp remains the same because your kVp doesn't change based on distance. Your penetration doesn't change when there's a change in distance. You still have the same wavelength, the same frequency, the same energy that you're passing through the part with. The only thing you change is the quantity of photons that you need with that kind of penetrability. So your penetrability doesn't change, just the amount, the quantity changes. And that is the direct square law, or the density maintenance formula, or the mass distance formula, or the exposure maintenance formula. Okay? Very similar to inverse square law, except that D1 is over D2. If you have any questions about that, hopefully it cleared it up. If not, be sure to ask, and we will make sure to clear that up on our next meeting. Thank you.